So go ahead and get started. Move everything around. We're going to do 12.8, which is dividing polynomials. 12.7, we divided polynomials. And what we were doing was like a polynomial, right? So something with many terms in the numerator. And then we just had a monomial in the denominator, right? So it's just like one thing. So we would do like a polynomial divided by 2x or 3x or whatever, right? Like it was just one term. In 12.8, I got it. In 12.8, what we do is divide a polynomial by a binomial. And the way that we did it before, like we pulled out the GCF and then like things canceled, right? That's not how we do it here. The way you know which way to solve the problem is what's in your denominator. If it is one term, then you pull the GCF and you do the math that we did last time. If it's two terms, what we have to do is called long division. And I'm not even kidding you, it's literally one of my favorite things to do. Make sure I got everything here. I really like writing in pencil, y'all. So this is definitely not going to be a review. Give me a second. Let me see. Oh, awesome. Okay. So let's go and get started. It is 12.8 dividing polynomials. Remove this. There we go. Okay. Dividing polynomials. I have a green pencil like this. I think it writes better than this black one's weird. Okay, so I'm going to do an example, really basic, just numbers, elementary-ish type of long division so that you can really see like the steps that you follow. And then what we're going to do is do one with the polynomials, and you'll see it's the same steps, okay? So let's just say, let's go and write right here. This is going to be long division. So this is literally just a review, right? Say that you saw a problem and it was like 3,983 divided by 26. So the 3,983, that would be my dividend, and it's being divided by 26. This would be my divisor. Okay. Now, the way we would do this, because usually in math class, it's not use your calculator, it's compute it by hand. With the polynomials, you have to do it by hand. But let's pretend like you were told that you had to write out all the steps. You couldn't use your calculator. This is how we would do it, right? This is saying the same thing. This is saying 3,983 divided by 26. So what we do is we look to see if 26 can, divide equally into these numbers. If you start with 3, well, if I do the division there, like that's not going to work, right? If you look at your 39, I know that 26 can go into 39 one time. So technically, it's like I did division there. 39 divided by 26. It only goes in there one time equally. So then there's going to be a difference of that. What you do here is multiplication. 1 times 26 is 26. And then here, don't we subtract? I'm going to grab a marker because I know I'm going to need it. Right there, we subtract. There we go. I'm trying to see what I can see here. I'm going to scoot up some. Okay, well, when you do this subtraction, what do I get? I get 13. And then the next step would be to bring down your next term, which is 8. So now I'm looking at how many times can 26 go into 138, right? That's 138 divided by 26. The number of whole equal times would be 5. I get 130, and then we subtract, right? 138 divided by 130. I'm sorry, subtracting 130 is 8. Bring down this last term. Now 83 divided by 26. Well, that will equally go into that 3 times because 26 times 3, 78, and then you subtract. Difference here would be 5. This is what we call a remainder. If your remainder is 0, then that means that your divisor equally went into your dividend, right? There was no remainder. Because I do have a remainder, that means that it doesn't go equally into it. It goes into it. The way that you write, I'm going to kind of come up here. I'm going to zoom out some. Oh, just kidding. It won't let me zoom out. Hopefully that's better. Okay, the way you write your remainder is we would say that this answer is 153, and then you've always done your remainder over your divisor, like in fractional form. So we would say 5/26. That would be the answer. So dividend divided by divisor, your answer to a division problem is going to be a quotient. This is how many times it could equally go into it, but we do have a remainder of 5/26. Those exact same steps are what I'm fixing to use, but with polynomials, with x squareds and x to the fourths and this and that, and it's going to be just like this. So I really just do that to show you, like, you know, this process, right? Okay, so let's go ahead and do this first problem. Not cover up that little microphone there. Okay, say what we're given. In the numerator is this polynomial. It's x squared a negative x negative 42 divided by, and then in the denominator we have x minus 7, x negative 7. So in this form, same thing as writing it the way we did that first problem. This is saying this polynomial divided by this binomial. So this is dividend, this is divisor, and the answer is our quotient, right? So what we're going to do is we're actually going to take the numerator and we're going to divide it by, put it in the little house, right? And on the outside, we'll have x minus 7. Divided by x minus 7. And it's different than what we did in 12.7, y'all, because my denominator, you see how it's not just one term, there's multiple terms. That's why we have to do it this way. So, okay, now y'all follow me. The first step, what we do is we're going to take the first term in our dividend and we're going to divide it by the first term in our divisor. So that looks like this, x squared divided by x. Well, variables are the same, right? X squared divided by x was keep and subtract. Don't I just get x right here? This quotient, after I did that division, needs to line up with its like terms. And so I wouldn't put it right here because that would be an x on top of an x squared. That's not right. But this x with the exponent of 1 matches this one. So that's where it goes. That's where it gets placed, is right there. So just like here, when I did the division and I had my 1, that next step was to multiply. I took this and I multiplied it to this. So you do division, multiplication, and then subtraction, bring down. Division, multiplication, subtraction, bring down. That's the process, okay? So we just did the division. Now we need to do the multiplication. So what you're going to do right here, this multiplies to this whole binomial. So you're going to do this times this and this times this, with your answer also lining up under your like terms. So if you do x times x, for multiplication, we keep and add, right? And it goes, because that's an x squared, it goes right here underneath this x squared. And I'm going to tell you right now that when you do that multiplication, that first time, right, this is our first time to do the multiplication, these have to be the same because they're going to be like, they need to cancel each other, okay? Okay, so I've done the x times this x. Now I need to do x times negative 7. Well, 7 times x is 7x. Signs are different, so it's negative. That negative 7x, that goes right here next to our x squared. So negative 7x. So remember I said divide multiply, subtract, bring down. So we did our division. We did our multiplication. Now the next rule says to subtract. This is very important. So I got a green marker. What we're going to do is we actually need to subtract these two terms from these two terms. So change their signs. Whatever they are, make them the opposite. So divide, multiply, subtract. In order to subtract, change the terms, and now let's actually perform that subtraction. If I have 1x squared minus 1x squared, don't those go away, right? They're the exact same thing with the different signs. Those go away. So you just scooch on over to the next term. That has to happen. If right here in that first step of, all of your, when you step down, if those don't go away, your multiplication or something's wrong. Okay, so then scoot over. I have -1 and a +7. So signs are different, right? So what I would do is subtract, keep the sign of the larger. So that's a +6, and my pencil acted funny. Keep and keep, because I'm combining like terms here. So divide, multiply, right? Here's my multiplication. Divide, multiply, subtract, bring down. Second verse, same as the first. Do the exact same thing again until you're done with the problem. This is the one you look at now. First we looked here and we did this divided by this, right? And the answer went up here. Now we look here. So we do 6x divided by x. If you do 6x divided by x, your x's cancel, right? The only thing I'm left with is 6. So 6x divided by x is 6. There's no variable. So it gets written right here on the term that also has no variable because we're lining things up. These are both positive. So it's a +6. After you do your division, then you go through and you do all that multiplication. So that's literally taking this. This is called a quotient, right? I did a division. That was the answer. You take this quotient, we're going to multiply it to everything right here. So 6 times x is 6x. And you see how I told you these always need a match, because when I do that subtraction, they need to cancel each other out. And then 6 times 7 is 42. Those signs are different, so it's negative. Now we subtract them, which just means change their signs. Whatever their signs are, they get changed to the opposite. Same exact things, different signs, those cancel. I wouldn't put like a 0 here or anything because it kind of just gets like really messy and like cluttery, If you wanted to just draw a line through them, that's fine, because that literally is like, hey, those went away. Like, that's okay. If those don't go away, something in your previous step was wrong. So now scooch right here. -42, +42. Same exact numbers, right? Same exact value, different signs. Don't those go to 0? That's my remainder. So if something has a 0 remainder, that means that the divisor equally went into the dividend. So our answer for this problem is what you have written right here. I don't know what this is called, little house. What you have written right here, that's your answer. That makes sense, y'all? It's real steppy. You know what I mean? Like, there's a bunch of little steps in there. I think I have 4 problems for us to do, all pulled from the homework and stuff. So let's go ahead and do the next problem. Okay. Problem 2. In the numerator, y'all, we have 4x squared, +2x, a -1, divided by 2x minus 3. 2x and a -3. I know I have to do long division here because my denominator, if it was like that, if it was just 2x, that's like what we did last time, right? Pull GCF, see what you can do, things cancel, boom, you're done. Because this is not one term, it's two terms, you have to do the long division, okay? So literally, let's take our dividend, put it underneath the house, put my divisor on the outside. When you do long division, you divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. What is that? Divide, multiply, subtract, bring down. That's not a pretty acronym. But divide these two terms, right? Our quotient's going to line up wherever it needs to. Then I'm going to multiply it. Then I'm going to subtract whatever I get here, like the product, right? Whatever my answers are to my multiplication. And then I'm going to bring down the next term. Okay? So what you do is you take the first term in your dividend and you divide it by the first term in your divisor. This answer, right, the little quotient that I get here, I'm writing it like this so I can see what it is beforehand because I'm going to line things up, okay? They have to be all like terms. So y'all, if you do 4 divided by 2, you just get a whole number 2, right? So it's no longer in like a little fraction. And then if you do x squared divided by x, when you divide variables, you keep and subtract. 2 minus 1 is just 1. This is the quotient from dividing these two terms. It gets written on top of the house, on top of whatever has like a like term with it, like meaning it has the exact same variable, exact same exponent. Because this is just x to the first power, it would line up with this one. So divide, multiply. Now I did my division. Now multiply. And what I mean by multiply is you take this, the quotient that we found, and you multiply it individually to this and then to this. So both of your terms in your binomial. So 2 times 2 is 4. X times x is x squared. If you wanted to go ahead and do this so that once you see it's x squared, you know it gets placed right here. Okay. And then you would do the multiplication here. 2 times 3 is 6. Signs are different, so it's negative. X times no x is still just x. Divide, multiply, subtract. You notice how the 4x squared and the minus 4x squared, they went away, right? They're additive inverses. I needed that to happen, so I'm glad that happened. If you scoot over right here, I've got a positive 2x and a positive 6x. And that's just adding, right? So whenever I'm adding, I look at the signs, look at the coefficients, and keep and keep. Well, 6 and 2 make 8. Keep your variable, keep your exponent. So divide, multiply, subtract. Now bring down. Whatever's there. Whatever's there. The sign, every single thing. Whatever the next thing is to bring down, you bring down the whole entire thing. So this is literally, I'm bringing down a -1. Okay, so after I bring this down, I literally loop back around to the front. Divide, multiply, subtract, bring down. But now I'm looking at this term, right? I started here, did my division. Now I'm here, so I'm looking right here. I do this division. I get 8x divided by 2x equals 8 divided by 2 is 4x divided by x. Those just go to 1, right? Like, because that exponent rule that we learned, it's just kind of easier to say they're the exact same thing, that cancel. So I just get 4. And because this is positive and this is positive, it's a positive 4. After your division, you multiply this times everything. 4 times 2 is 8. X times no x is just x, and those are positive. 4 times 3 is 12. Signs are different, so it's negative. And then you subtract. What I mean by subtract, y'all, technically what's happening, do you see how this is what I had right here? You're subtracting both of those terms. Do you see how what happened though is their signs changed? So instead of putting it in parentheses and then distributing it, I mean, it's just change their signs. Whatever they are, change them. Now, where you're looking, we're combining, right? This is subtraction right here. Those cancel because they are the exact same thing. And then if you scoot over right here, I've got a -1 and a +12. Well, those signs are different. So I would actually subtract. I'm going to keep the sign of the larger. And so 11 is my remainder. So using that example that we did at the beginning of class where I had 5/26, right? You take your remainder and you write it over your divisor. Let me write this. Let me see. I think I spelled divisor wrong. Divisor. Y'all, that first problem that we did, my remainder was 0, right? Divisor. I'm pretty sure that's right. My remainder was 0. There was no reason to write it in remainder over divisor form because it equally went into it. If right here for your remainder, you actually get a number, you write it quotient, right? That's the answer that we got up here. So 2x plus 4 plus 2x plus 4 plus, what you do is you put your remainder over your divisor. Remainder is 11 over my divisor. That's what you divided by, right? That's 2x minus 3. That would be your final answer. Okay, got 2 more examples. We're on track. And then I'll get y'all's review. I want to have it done by tomorrow. And like I'll email it to everybody, okay? Okay. So problem 3. 8x cubed negative 12x squared negative 28x negative 8 divided by 4x plus 4. So this is saying my top is being divided by my bottom. So I'm going to go ahead and write my dividend. And then I'm dividing by 4x plus 4. Okay. So because there's a few more terms, I will come to the side and like do all the little multiplication and the division and stuff, okay? So we do the first term in our dividend divided by the first term in our divisor. That's how you get started. So we do 8x cubed divided by 4x. 8 divided by 4 is 2. X cubed divided by x. When you divide variables, you keep and you subtract. 3 minus 1 would be 2. Since I see that this is 2x squared, I need to write it above the x squared term. It doesn't get written here because that's an x cubed. It gets written here because that's an x squared. So you write 2x squared. That's an ugly 2, but that's a 2. After we divide, we're going to multiply. This 2x squared times everything right here. 2x squared times 4x. 2 times 4 is 8. Signs are the same, so it's positive. X squared times x. When you multiply, you keep and add. Do you see how I got right back to this exact same thing right here? It needs to be that because they're going to end up canceling. I can't talk. They're going to end up canceling each other. So that lets me know, okay, my division was good. Like everything's good so far. So you write it underneath its like term because it's x cubed. It gets written underneath x cubed. Now let's do the quotient right here that I found multiplied by the second term in the binomial. You get 2x squared times 4. 2 times 4 is 8. Signs are the same, so it's positive. X squared times no x squared is still just x squared. Okay, so that positive 8x squared gets written right here. I no longer have anything else on the outside, right, to divide it by. So what I do is I subtract. And what I mean by subtract is change it, whatever the sign is. This first term was positive, now it's negative. This second term was positive, now it's negative. Now we do this math here. It's a combination. It's adding or subtracting, right? I always just say combine. These are the exact same thing. They went away. You can just scoot over. That's a negative, big old, why it was so dramatic. That's a big old negative sign. 12 and 8 signs are the same. So if I add these together, don't I just get more negative, right? I had negative $12 in my bank and I spent 8 more. Now I have a negative $20 in my bank. You keep and keep. And then you bring down. And then literally you repeat all the steps over again. Okay, so we do this first term divided by this first term to get an answer here, and then you multiply. So start right here. We get negative 20x squared divided by 4x squared. 20 divided by 4 is 5. Signs are different, so it's negative. X squared divided by x squared. Oh, why did I do that? Whew, I was like, hold on, that ain't right. Y'all, do you see when I wrote my 4x, I accidentally put squared here? Yeah, no, say something. Seriously, say something. Because sometimes I might not even catch my mistakes. And then later I'm like, oh, you gotta be kidding me. Like, I'm so sorry, y'all don't hate me. That was literally, like, I just got ahead of myself. I'm doing this first term divided by this first term of my divisor. So whenever I went to write it, though, I accidentally did a squared here. So here we go. 20 divided by 4 is 5. Signs are different, so it's negative. X squared divided by x. Whenever you divide variables, you keep and subtract. So 2 minus 1 would just be 1. So x to the 1, x to the first power. Y'all, if you did get nothing here and you go to write it here and you notice, oh, that would have been written here, that should have been like also the first hint, like, hey, hold on, I did mess up because there needs to be something here, right? That's why when I looked up, I knew something wasn't right. Okay, so this negative 5x, that little quotient to this little bitty division problem, gets written above its like term. And now we multiply. You're going to take what we just found right here, this negative 5x, and you're going to multiply it to everything in your divisor. So what we end up getting is, let me just write it right here, negative 5x times 4x. 5 times 4 is 20. Signs are different, so it's negative. X times x. When you multiply, you keep and add. And you notice I get this exact same thing. Y'all, that's literally like a little check while doing the problem. Right? I mean, that's what you have to get. So if you don't get it, something somewhere's not right. And then you do this little quotient times the second term in our binomial. Okay, so what we get is negative 5x times 4. So if you look at that, sorry, things like itch in my hand. If you look at this, 5 times 4 is 20. Signs are different, so it's negative. X times no x is just x, right? Not it is just x, it just stays x. And then so you write your negative 20x right here. It was divide, multiply, subtract. So both of those negative signs just became positive signs. Whenever I combine these two terms right here, those are additive inverses because they are the exact same coefficient, the exact same variable with the exact same exponents. They're literally 100% alike, but they have different signs. So they end up going to 0, right? Scoot over right here. What I notice is their signs are different. So I'm actually going to subtract these two coefficients and then I'm going to keep the sign of the larger keep and keep. So if you do 28 minus 20, you get 8. Keep the sign of the larger, that would be a negative 8. And then you keep the variable, keep the exponent. That's basically because I had $20 in my bank and then I spent 28. So I'm only 8 negative, right? It's just like the difference of them. And then you bring down. Got a little cluttery going on right now, but now So like I always say, second verse, same as first. Divide, multiply, subtract, bring down, right? Just now brought down. Now we loop back around to divide. You use this first term and you divide it by this first term in the binomial. That is your divisor. So negative 8x divided by 4x. 8 divided by 4 is 2. Signs are different, so it's negative. X divided by x. Those went away. They cancel. They turn into 1, right? So what I get for my quotient is a negative 2. That goes right there. And now we multiply. 2, I'm just kind of running out of room here. We're going to do a negative 2 times 4x. 4 times 2 is 8. Signs are different, so it's negative. No x times x is x. And I notice it matches exactly what I have here because it needs to, so that's good. And then let's go ahead and do this multiplication right here. Y'all, 4 times 2 is 8. Signs are different, so it's negative. And then right here, isn't this where we subtract? And what I mean by subtract is change their signs. Anyone notice what happens right there? 8x and an 8x, same thing, different signs. Doesn't that go to 0? And then negative 8, positive 8, doesn't that go to 0? So this is saying that if I have 8x cubed, a negative 12x squared, negative 28x, negative 8 divided by 4x plus 4, my answer is just this quotient right here. I don't have anything else because my remainder was 0. This binomial equally divided this polynomial. Okay, y'all, one more problem. Okay. Fourth and last problem. 2x to the fourth plus 3x cubed, negative 6x squared, negative 3x plus 6 divided by x squared and a negative 2. I think there's one like we just did, and I think there's 1 or 2 of these. You just notice that it went up a degree, right? We started with an x squared. I did another problem with x squared. We did a problem that started with x cubed. Now this is x to the fourth. So it's just a couple of like added steps, basically. Okay, so what this is saying is numerator divided by denominator, which looks like 2x to the fourth, positive 3x cubed, negative 6x squared, negative 3x, positive 6 divided by x squared, negative 2. Okay, so you take the first term in your dividend and you divide it by the first term in your divisor. I'm trying to move stuff around here. So what we get is 2x to the fourth divided by x squared. 2 divided by 1 is 2. Signs are the same, so it's positive. X to the fourth divided by x squared is keep and subtract. Because this has an x squared, it's going to be written above x squared. So that's 2x squared. Okay. So now what we do is you multiply this times your divisor. So we do 2x squared times x squared. This equals 2 times 1 is 2. Signs are the same, so it's positive. X squared times x squared is keep and add. Because it's 2x to the fourth, it gets written under the x to the fourth term. You still need to do this multiplication right here, which is 2x squared times a negative 2. 2 times 2 is 4. X squared times no x squared is still just x squared, and that's actually going to be a negative 4x squared. So here, you see how this is at 4x squared? And right here, I've got an x cubed. What you have to do is do 0x cubed negative 4x squared. And then now we'll combine. We'll subtract. So whatever the signs are, change them. Change it, change it, change it. And now combine them. So those go away, right? Right here, these first ones. And then right here, I've got 3x cubed minus 0x cubed. Well, that's just 3x cubed. And then right here, what I have is a -6 and a +4. Signs are different. So we subtract, keep the sign of the larger, keep and keep. And then because I have two terms here, I didn't actually solve this problem. Because I have two terms here, I feel like we could bring down, because that's what we did, that we're going to have to. Okay, and then we bring down. And then now let's do the work for this, which is going to be this divided by this. Answer goes here, and then multiply. So 3x cubed divided by x squared. 3 divided by 1 is 3. X cubed divided by x squared is keep and subtract. I get 3x. And so that 3x goes right here. That's a positive 3x. And then now you take this and you multiply it into your binomial. So we're just going the opposite way now, right? 3x times x squared equals 3x cubed. That's this term, so that's good. That's what it's supposed to be. And then now we need to do this times this. So if you do 3x times a -2, 3 times 2 is 6. Signs are different, so it's negative. X times no x is still just x. When you look at this product, I notice that it has an x term, just x to the first power. It wouldn't go right here because that's x squared, right? It would go right here. So we have a -6x, but you don't want to just leave this blank. You just go ahead and put plus 0x. I have to scoot these up. Doesn't really help at all. What is like in my way? Okay, that's a little bit better. Okay, so now this step was to subtract them. Whatever their signs are, they change. 3x cubed minus 3x cubed goes away, comes 0. -2x squared and a -0x squared signs are the same. So you add them together, keep their sign, keep variable, keep the exponent. Keep and keep. Excuse me. And then right here, signs are different. So you would subtract, keep the sign of the larger, keep and keep. And you bring down. So now let's do this division so that we then can do that multiplication. This is -2x squared divided by x squared. 2 divided by 1 is 2. Signs are different, so it's negative. X squared divided by x squared, those go away. You just get a -2. So that's what gets written right here above that plus 6. Now you take this -2 and you multiply it to everything. So we get -2 times x squared. So that is just -2x squared. -2x squared. Those match. Good. They have to match. They're supposed to match. So it's a good thing they do match. Then we're going to do our -2 times our -2. 2 times 2 is 4. Signs are the same, so it's a +4. That doesn't have a variable. It's just a constant, right? So it's going to go underneath the term that also is just a constant. And then you could fill in this term right here with just a plus 0x. Okay, so now we combine them. We subtract them. Whatever their sign is, it changes. Those cancel. Good. That's what we wanted. Scoot over here. I mean, a positive 3x and minus or adding nothing basically is still just a 3x. That's why we can do that. Mathematically, it didn't change anything, but it's just kind of like for aesthetics, like so it looks right. And so there's filler and no gaps. That's why we could do that. Okay. So then if you scoot over right here, we've got a positive 6 and a negative 4. Signs are different. So you subtract, keep the sign of the larger number. And then what do I bring down? There isn't anything else to bring down. So that is our remainder. And so whenever we put this in like our answer form, you do quotient plus remainder over divisor. So our answer is 2x squared plus 3x minus 2 plus 3x plus 2 over x squared minus 2. Yeah, that's the right answer. Oh, let me. So we got the quotient plus remainder over divisor. That makes sense, y'all? Real steppy though, right? And it's like, even though, I mean, we've done that little division before, we've done that little multiplication, we've done, right? Like we've done all these steps, but now it's all thrown into one big problem. It wasn't really an acronym. I just kept saying the same thing over and over again. So I was like, let's go ahead and write it. Like, what am I saying? Okay, so the steps that you do, that you follow is divide, multiply. That ends in an E, right? Divide, multiply, subtract, bring down. And the first example I did in the beginning of class, hold on. There's the work for 4. 1, 2, 3, 4. Was looking at a long division problem with just numbers. It's the same process. I divided 39 by 26 and it equally could go into it one time. Then I multiply. 1 times 26 is 26. Then you subtract. You get your difference. Well, this would be my difference, 13, right? And then you bring down. So it's divide, multiply, subtract, bring down, divide, multiply. I mean, it follows the exact same steps, but it's just a little bit crazier because I got polynomials. Okay, y'all. So that's it. I'm going to work on the review and I'll send it to y'all on, I want to do it by tomorrow. And the exam is going to be a week from today. It's on Monday. Turn this off.